All right, so just an overview of what we will be talking about today. So as we start talking about data visualization, we'll first do a little bit of a background on what data is. We'll sort of define data and some kind of general types of data. Um, we'll talk about the distinction between data and statistics or information, which sort of leads us into data visualization and why you want to visualize data and really think about appropriate visualizations for whatever data type that you're working with. So we'll talk about types of data visualizations, designing appropriate data visualizations, and will be a couple of examples in there of different resources that you can use, different tools, and we'll sort of finish up overall with some places where you can learn more, some places where you can play around with visualizations or read more about these. All right, so I first like to start off with just talking about what is data. So we're talking about data visualization. So part of that is data. So there are many different definitions of data. If I got everyone into a room and just asked them what their definition of data is, everyone is going to have a completely different definition. It depends often on sort of what disciplinary area you're in, what research project you're working on, what context that you're looking at the data for. So there's lots of different ways you can use data. But for thinking about data in our terms today, we're just going to think of that as facts and information collected together for reference and analysis. So data is sort of that raw information, those raw values, that raw text information that you collect or that you look at, and then further analyze and visualize. And we note that data by itself is simply facts or pieces of information. It doesn't have any meaning by itself or tell any sort of story. To be able to do that, it has to be sorted, analyzed, visualized, etc. And we often use lots of different softwares, tools to do such a thing. So just an overview on some of the different types of data that you might be working with. And this is really important when thinking about what types of visualizations you might want to use for your data. We're just going to keep it very sort of broad here. There's lots and lots of different types if you really want to drill down to specific areas. But sort of the two big umbrellas that we think of data under is quantitative data and qualitative data. So quantitative data is numeric data that is used when a researcher is trying to quantify some sort of a problem. So if you're trying to answer questions such as how many of something, etc. It's often counted or compared on some sort of a scale. So you often have sort of a minimum, maximum, some sort of scale that you're measuring with. And it's processed oftentimes using spreadsheet and statistical software. Some examples include Microsoft Excel, Python, R, etc., along with many others. Qualitative data describes qualities or characteristics of something. This often deals with sort of difficult to quantify dimensions. It's a lot of times you see text data. Text data is a type of qualitative data. This is collected through interviews, case studies, field notes, observations. And you can analyze qualitative data, doing some sort of coding with software such as NVivo to take that qualitative data, identify themes, and even perform some quantitative analysis. So if we think a little more specifically, but still sort of broad, we can think of observational data, experimental data, and simulation data. And these are types of data that you'll collect if you're doing some sort of a study, some sort of an experiment, some sort of research analysis. So observational data is captured through observing some sort of behavior or some sort of activity. It's collected, usually using like instruments or sensors or even just, the human eye. A lot of times if you're collecting field data, and you're putting sensors out in the field, you're collecting data over a period of time. This is observational data. Whereas experimental data, whereas observational data, you're just sort of letting something happen. You're not usually intervening in any sort of way. And experimental data is collected through active intervention by a researcher to produce or measure changes in different variables and to determine relationships between those variables. And then sort of going off of both of those, you have simulation data, which is generated using computer models. So this is done by imitating the operation of real world processes, often processes that have been collected through observational or experimental data and used to predict certain results, such as weather conditions, seismic activity, etc. And it's good to determine the likelihood of something happening under conditions that may not necessarily be feasible for one reason or another to collect experimental or observational data. And so we think about all of these types of data, you collect all these types of data, right? And then you have to work up this data. You have to make it into a readable form, a form that can be consumed by other academics, by the general public. And this is where we start thinking about statistics or information. So as we mentioned earlier, data by itself, if you just have like a spreadsheet of values or a sheet of text, this isn't really, doesn't really have any sort of meaning. It's hard to sort of get patterns out of that. But statistics, we think about this is the results of data analysis, right? So it's sort of its interpretation and its visualization. And this is often in ready to use format. The data has been processed. It's been put into some easy to read format. We'll talk about some common visualization types in a little bit, such as charts, graphs, tables, figures, etc. And this really allows you or someone looking at this to really sort of evaluate this data, to really sort of parse out what is important within that data, right? And so I bring sort of this distinction up because a lot of times in conversation, if we're just talking to one another, folks use the terms data and statistics pretty interchangeably. They use them kind of back and forth. And I know I do this in casual conversation or in conversation with colleagues quite a bit. Just do want to point out that sort of in the world of research and when we're really thinking about our data and where it starts to where it ends up, there is sort of an important distinction between those two. And so this is really where we get into data visualization. So once you have that set of data, as we sort of talked about earlier, you need to sort of represent it and visualize it so that it's understandable to your target audience. You need to sort of tell a story sort of about that data. So data visualization in its simplest terms is really anything that converts data sources to a visual representation. It communicates relationships amongst data points or a data set. And these relationships are often hard to see or to parse out from just the raw data, like if you have a spreadsheet or kind of reams and reams of data values, right? It's sometimes really difficult to just look at that and find relationships. Visualizations and sort of the process of visualizing this data is really helpful for sort of parsing out those connections. And it allows your consumers, your viewers to analyze and reason about data and the evidence. There are several ways to visualize data, and this depends a lot on the data type, what type of data that you're working with, the context for your data, the audience, so who your audience is it an academic audience or is it a general lay audience, general public? So you might have a data set that you visualize it a couple of different ways depending on who your audience is. And so we'll touch on some of these during today's session. Obviously, there's many different ways that you can visualize your data, and we won't have time to go through all of them, but we will try and touch on some of the more common ones that you might see and some places where they're used. All right, so before I go on, I just want to pause to see if anyone has any questions so far. If you do, feel free to put them in the chat. If you're all good so far, if you could just give me a thumbs up or a green check mark in Zoom, that would be awesome. All right, I'm seeing lots of check marks. Awesome. All right. All right, so now we'll spend a little bit of time here talking about some of the different types of visualizations. And I'm going to, for each of these, just sort of kind of give a brief summary of what these are typically used for, some of the situations you might see these, and there'll be sort of an example on the right-hand side for each one of these. And in some instances, we might talk about some things that you want to look out for, some instances where these might not be the right visualization to use. All right, so the first one we'll talk about is a bar graph or a bar chart. So bar charts are commonly used to compare several categories of data. So if you have many different categories of data that you're looking at, and you want to compare those, you want to compare those values, bar chart is a good option for that. One axis presents the categories being compared. So in the case of this chart on the right-hand side, we're looking at age groups. So 20 to 39, 40 to 59, 60 to 79, 80 plus. So it shows those categories. The other axis shows a discrete value scale. So we're looking at self-reported pain score here for this particular study. And you see we have a scale from 0 to 70. So that's on the y-axis or the vertical axis of our bar chart. So as I said, this type of data is categorical data. It answers the question of how many. It can be used to show like summary data or averages. One thing that it's not necessarily useful for is if you want to display continuous developments over an interval. So if you want to sort of show continuous data, a bar chart would not necessarily be a great example of that. We'll see another type of chart later that you could use that's somewhat similar, but a little different in purpose for that type of data. Line graphs, very, very common. You see these quite a bit in textbooks and in the news, online. These are used to display data that changes over time. So you have a single variable that's being measured and you're looking at how that changes over a certain time period. And these are used really to show trends, how that data changes over time. It can also be used if you're doing analysis on this to make predictions based on a data history over time. You can often, if you have several different data series, so this graph here on the right, bottom right, just shows one series, but say you have like 3 or 4 different series that you're comparing over the same time period in the same scale. These can be grouped. So you'll sometimes see, line charts that have 3 or 4 different lines on them, different sets of data. So you can compare those to one another. It is important when you're doing that to only keep it to so many lines per graph, like 3 to 4 lines, so that you don't oversaturate your reader or with too much data. All right, so the next one is pie charts. And these are very, very ubiquitous. If you've ever watched a presentation or, been in a room somewhere where somebody's talking about data, you've probably seen a pie chart. These are very widely used. And really the pie charts display data and statistics really in a format that helps you see the composition or the proportional distribution of the data. So it can be good for showing those relative proportions between different categories. Now, there are some downsides to pie charts, so they're really great if you just want to get a quick representation. But oops, went back, apologies. So when you look at pie charts, this one is really nice. It only shows 4 values, right? So this is fairly legible, fairly easy to look at and compare. When you start having too many values on your pie chart, so like more than 6 or so is kind of a good rule of thumb, the size of each of your segments becomes smaller and smaller and harder to parse out. So if you have large amounts of data, it makes it really difficult to compare between different categories. And it's also kind of along with that, if you want to make really accurate comparisons between groups of pie charts, it can also be difficult. So if you have more than one, since it is harder to distinguish the size of items sort of via area, because you're sort of looking at how much area of the pie or circle that takes up. All right, moving from pie charts to scatter plots, another very common type of visualization. This type of plot shows the relationship between 2 different variables. It's plotted often on an X and Y axis, and it's used to sort of see whether there's a relationship or correlation between 2 different variables, right? So like here we have age and we have our self-reported pain score using the same data set as before, now just looking at the individual data points instead of averages. So you can take a line chart and sort of fit this to see how close of a relationship they have, whether there's a strong correlation or a weak correlation or no correlation at all. All right, and so then the final 2 that I will just briefly talk about in sort of our tour of common data visualization types are histograms and span charts. So histograms sort of look similar to that bar chart earlier. This shows the distribution of data over a continuous interval or a certain time period. So here you kind of see continuous distribution of data. Each bar sort of represents the tabulated frequency at each interval. Sometimes you'll hear this referred to as bin. It gives an estimate as to where values are concentrated. So if you've ever seen like a bell chart or heard of that term before, it sort of shows you where the highest concentration of measurements or values are. It also shows you if there's like any extremes or outliers or gaps within the data. And then a span chart is used to display data set ranges between a minimum and maximum value. So if you have several ranges of data and you're sort of wanting to compare those and see if there's overlap or if there's data that's sort of spaced out from the other, span charts can be useful. And it really focuses the reader on the extreme values. So if you're really wanting to get information kind of on the values in between or on averages or data distribution, this might not be the best chart. But if you're wanting to compare ranges, see those minimum and maximum values, span charts can be useful. All right. So we've sort of looked at some different data visualization types. As I mentioned, there's many, many more. And I'll show a really great resource here in a little bit where you can really sort of dig into each one of these, see which one of them is appropriate for you and your data and your projects. But now that we've talked about what kind of visualizations there are, now I want to talk about designing appropriate data visualizations. And so visualizing data, can be a somewhat tricky proposition at times, right? Because there's often more than one way to correctly visualize something. And this varies because of a lot of different factors. So when you're sort of planning a visualization, you need to make one for your project. You have a data set and you're like, now I need to visualize that. There's a few questions to sort of consider. One of those questions is, who is your target audience? What is your audience's knowledge? What is their expertise level? Is this for an audience within your research field? Or is this one for a sort of more general audience? And this will kind of affect the way that you think about how you visualize that data and make it understandable to someone with that knowledge level. What are you trying to show? What message are you trying to communicate with the data? And so this is where you really think about those relationships between the different data points in your different data series and the different variables that you're trying to sort of focus folks in on and think about. And so no matter how you present it, the visualization needs to highlight those items, right? There's often a lot of different data that you can pull out of a data set. And there may be too much to put in one visualization or to concentrate on. So really kind of focusing in on those important aspects can really help your reader follow your thought process. And then what is the appropriate visualization type for your data? So we've talked about a few different visualization types, and there's many more out there. A lot of these can work for different data sets. And sometimes for using software, as we'll see in a little bit with a general example, they'll give you a lot of different options for how you could, in theory, visualize your data. But you really want to choose one that highlights the relationships between the data points or the particular data types. And so I show a couple of examples here on the right-hand side. So one of these is a pie chart, and one of these is a bar chart. This is showing the same data set. It's a breakdown of an investment portfolio with a few different categories. So you'll see if we're looking at the pie chart at the top right, we can really only discern those kind of general proportions, right? We can only see generally how much of that pie or how much of that data set is made up of each of those categories. We can't really get any precise values out of it. Whereas at the bottom in the bar chart, we can better parse out what percentages or what the composition is of that portfolio. Now, neither of these is inherently wrong. If you just wanted to do a quick comparison of sort of the proportions and how much of the data set is comprised of each of those different types of stocks or bonds in that portfolio, you could use the pie chart at the top. But if you want to sort of parse out what those exact values are, kind of drill down into, that exact composition, do comparisons, the bar chart at the bottom right would probably be your better visualization option. All right, so one important thing to think about when we're sort of visualizing our data is color palette. Color is a really, really powerful way to sort of highlight data, sort of tell the story that you want your data to tell. And so appropriate coloring within your visualizations can be really, really helpful in this regard. And if done incorrectly, it can actually make your visualization more confusing or harder to look at or analyze. So when we think about sort of general color palettes, right, there's sort of three that I want to point out. And you've probably seen these different like bars before with these different color schemes on them. If you've used any like software or had to change colors for a chart or a presentation or something like that. So the first type is what we could call a qualitative palette. And this is good for categorical data. So data with different categories that doesn't really have an inherent order. So if you have things like country or state or gender or race, if you're comparing different categories of data, but there's not really an inherent order to that data, a qualitative data palette or color palette can be good. And in this type of situation, each possible value is assigned a color. So like, teal, I believe, yellow, purple, etc. And when you're using this type of palette, it is important that each of the colors be distinct enough. So they be different, like completely different colors so that you can distinguish between those groups, so that you can tell each of them is a unique category. The next type is a sequential palette. And this is used for data that is numeric or does have a natural ordering. So there is some sort of continuum that you're looking at a certain category of data. And in this case, your colors are assigned to data values in some sort of continuum, usually using either different hues or different lightness, or in some cases, both. In general, this can vary a little bit, but in general, if you're using lighter backgrounds, like we've got a white slide, so we've got a very light background, lower values on your scales are usually associated with lighter colors. So we've got sort of light green for our 0, 10, 20%. Whereas higher values are often associated with darker colors, so like our 50, 60%, and so on. If you're looking at this on a dark background, you might see the opposite. So you may see this completely switched around. You'll also sometimes see hues when you're looking at this, in addition to shading. So you might see what we call warmer colors, like red or yellow, for maybe data on sort of the lighter end, while you see cooler colors on the darker end. So folks will also use hue to distinguish data within visualizations as well. And then the third type, sort of similar to the second one, is our diverging palette. And what this is good for is it's good for data that has a meaningful central value. So if you have like a value for two different data sets, two different palettes, and say that's 0, right? You essentially can combine those with each of them having that shared value or that shared endpoint. So you'll sometimes see, like age or some other distributions, right, with several of these sort of going down in a pyramid-like shape. And essentially they've combined two of these sequential palettes, values larger than that central value, so say larger than 0, are assigned to one set of colors. So we could say like the blue colors over here on the right, whereas the values on the other side of center are assigned a different set of colors. So like this orange, brownish color. I'm not even sure what all of that is myself. But these distinctive hues, they really make it easier to distinguish between like positive and negative values if you have that in your data. Now, when we think about color, there are some things to think about when you are using color in your data visualization. So color is awesome. As we said, it's very powerful. But there are instances where it can actually hurt a visualization or sort of diverge or detract from the point you're trying to make. So the first sort of tip is to avoid unnecessary usage of color. So we say that color is great, but it's not necessarily required for every single type of chart, right? Not every chart will need multiple colors. If there's only 2 variables that you're looking at, like you're doing a bar chart with 2 different variables, you don't necessarily need to do color. Just sort of utilizing those vertical or horizontal positions or their lengths will often suffice. Color can become more important or useful if you have 3 or more variables, if you have several variables, or if it's specifically a component of a chart. So if you're using like a pie chart, right, you'll definitely need to distinguish with different colors. You want to be consistent with color across charts. So if we take a look at these charts here at the bottom right, we sort of have this line plot, right? And then we have this bar chart right next to it. So if you have a report or you have a dashboard that includes multiple charts that refer to the same group of data or the same variables, it's the same like data sets, or you pulled from the same data sets and you're just comparing them in different ways. You'll want to make sure that the colors match across those charts so that you can more easily compare that data. Avoid high levels of color saturation and brightness. This sort of helps to reduce eye strain and sort of allows room for highlighting elements that are important by maybe giving them a bolder look compared to other elements. So you see this chart up here at the right. This is BART hourly entries. for 2018, you'll see some of this data is grayed out. So it's kind of been put to the background so that we can really focus on like 4 different particular sets of data. So in this case, 4 different stations. So this is one really good technique if you want to sort of focus your reader on sort of different parts of the data, but maybe still have that other sets of data there for like comparison purposes or what have you. And then the final point that I always like to make, just in general, do not forget when you're doing your visualizations about color blindness. Color blindness is something that affects a certain percentage of the population. This often causes confusion between certain shades of colors, such as red and green or blue and yellow. So it's really important to sort of keep that in mind when you're designing a visualization that may have several different colors in it. Making sure that those colors are distinct, it can be parsed. So it's good to try and vary dimensions other than just hue alone to indicate the value associated with a color. And there are different color blindness simulators or tools out there to get an idea of whether your final visualization will be understandable to others. So those can be useful as well. All right, so before I go into this, I'll be doing a little demonstration. I just want to pause again, see if anyone has any questions. As I said before, you can enter those in the chat. If not, again, appreciate a thumbs up or green check mark. And then we'll continue with the rest of our workshop. All right, awesome. All right, so now we're going to talk about this really, really cool resource. This is called the Data Visualization Catalog. And for this, what I'm going to do is I'm going to stop sharing my screen real quick and navigate to this tool. All right, so now you should see the data visualization catalog. If you don't, please let me know. Oh wait, I do have to actually start the share again. Now you should see it. All right, so I'm going to put the link to this in the chat so that you all have this and can take a look at this, browse this if you wish. But this is a really great resource that contains a wide variety of useful information on different data visualizations. And it sort of allows you to search by the function of a particular visualization or how you want to communicate your data. And they sort of go into more detail on some of the visualizations we've talked about today, and even some more different types that you might be interested in. So if you look at this, there's several different buttons here on sort of this front page. So if you're wanting to, say, make comparisons with your data, say you've got a spreadsheet with, like 5 categories of values and you want to make a comparison, but you're not sure which visualization type might be appropriate. You can click on this comparisons, close out the ads that might come up. And then you get to a page that gives you a really nice list of different visualization types. So you'll see we have our bar chart here, our histogram, line graph, but then you'll see all kinds of other different types as well. And here it'll divide it up to, say, with an axis. So if you're looking at like an XY plot or something with an axis, or something without an axis, such as a pie chart. Or a donut chart, similar to a pie chart, just sort of without the middle. But what will happen when you click on, say, one of these, like say we click on multi-set bar chart, What this will do is it'll bring you to this little informational page. It'll give you a couple of examples of what this looks like. It'll give you this sort of nice anatomy. So this is just a very general, like, here's what each of these mean. So bar length equals value amount, category A, category B, scale, etc. And it'll give you a sort of nice, quick description on what that visualization type is, when you might use it, and sometimes similar names, because you'll hear really similar names for some of these visualization types as well. And then you'll even sometimes see different tools that you might be able to use to generate this visualization. And we'll talk about those more in a second, but some of these will be sort of online tools. Some of them will be like software for your computers. So this is a really, really nice informational resource. You can see there's a lot of different things on here. So I highly encourage you, if you want to explore different visualization types, if you're just interested in how you might take your data and visualize it, you know, like these population pyramids earlier, where we were talking about our diverging palettes. This is sort of one example of that. Take a look at this resource, explore it. Always happy to talk more about this later on if you sort of get into it and have questions on that. All right, so now we'll talk a little bit about tools. I mentioned those when we were looking at the data visualization catalog. So we've talked in general about visualization types, some things to look out for when you're visualizing data. Now we'll just talk briefly about tools. I don't talk about tools a whole lot. I don't go into too much detail in this session because each one of these tools could really have its own workshop or set of workshops, right? You could spend a whole hour, hour and a half just learning how to do visualizations in these tools. But I do like to point out some of the more common tools that you see or that you might use or hear about to visualize data. So I sort of divide these up into the proprietary tools, which are tools that you need some sort of a license for. There's often some sort of a fee, or these have some sort of a cost. Some of these are available through the university. So like your Microsoft Excel, your Microsoft Power BI, these are available through the university. So if you're an FSU faculty, staff, or student, you can use these here. You also have other software that while it may not be specifically for visualization, it has a strong visualization component, such as MATLAB. And then we talked a lot about tabular data today, but if you're looking at you know, like GIS data, there's also ArcGIS for the proprietary version. And then on the sort of free or open source side, there's QGIS. But there's several others. If you're looking at sort of free or open source tools, there's many options to choose from as well. So these are some of the most common, like Google Charts, or the ggplot package within R, or Python has some packages for visualization as well. So these are really, really powerful tools. You can do a lot with these. You know, if you have any specific questions on any of these tools, we're always happy to sit down with you, sort of help you work through visualizing in these specific tools. And in some of our other workshops, we do go a little bit more into examples on how you might visualize with one of these tools. But just to sort of cap us off, I am going to do a very quick example. So I do have a data set here that I've linked. It's a data set containing commute data from 2013 to 2019 in some southern US states. There's a link to where the original data set is in the slides. And you can also download this data set. I'll put that link here in the chat. And if you go to this link, you should see just one file. It's a Google Sheet that contains 2 tabs, one with the original data and one with the sort of summary data or simplified data that I use when we're doing demonstrations or examples. So that is available for you if you want to sort of play around with this data, sort of try out different programs, save it in different formats to visualize this. We're going to use Microsoft Excel as a quick example. You know, there's many other programs. Excel tends to be one that a lot of folks have seen or have used. So I will go into this for just our quick demonstration. And I'm going to quickly share my Excel. And so you should all see an Excel spreadsheet. Let me know if you cannot see that. But this is the same data set as we had before. I just downloaded it to my computer and I'm using Excel for this example. So each of your different programs is going to have different ways to visualize that data. Some of it with inherent functionality built in, some of them, like we said earlier, with different packages. For Excel, if we go over to this Insert tab and you scroll over here to Charts in the middle, you can see there's several different chart or visualization types that you can choose from. If you click the little down arrow that pops up, says See All Charts, you can see, we'll click on All Charts, you can see many different types of charts here. Here, this is using the data that we have on screen to sort of show us an example. But you can sort of click through and see what each of these would look like. And this is where we sort of get back to earlier, you know, looking at the different visualization types and choosing one that's appropriate for your data, right? So you'll see all of those different examples in Excel that it gives you for how to visualize your data, right? But not all of them are going to actually make sense. So if we highlight this data here, and I'm going to click on recommended charts. And so that pops up a little box. I do want to ask real quick, can you all see the sort of pop-up that shows up in Zoom? I know sometimes Zoom doesn't like to show those things. Sometimes it does. All right, awesome. Yes, I know in some instances it will, some instances it won't. So if we're looking at this data and say we want to show how each variable, so how the commute time in each state changes over time, so per year, if we take a look at these different chart types, right? So we have a line graph, we have this sort of clustered column chart or bar chart, we have a stacked area chart, we sort of have this scatter chart, still sort of a line chart, etc. If you're looking at this and you're wanting to sort of do comparisons with these different data series, right? Which of these chart types do you think might be appropriate for this data? If you were to look at this and decide based on everything we've talked about, this is a good visualization, this helps me make comparisons. So take a minute, think about that. If you have an answer, go ahead and write that in the chat. And then we'll sort of finish up this example. Yeah, so we had answer clustered column or line, sort of depending on what emphasis you want. Yes, so those are probably the two that I would look at. And like we said, it really depends on, sort of what you want to emphasize, sort of what you want to compare. If we just want to, compare values across different categories, when the order isn't really important, we might use our clustered column chart. If we're wanting to look at trends sort of over time, over different years. So here we have, 2013 to 2019, we can look at our line chart. Right. So I'm just going to click on one of these because I want to show some other things you can do, at least in Excel. So I'm going to move this. I'm going to move this to a new sheet. So in Excel, you can sort of move this to a new area where you can do the visualizations. And I apologize, those are really, really small for some reason. But you'll see one thing you can do is go over here to sort of chart styles. You can sort of change the style here. You can even change the background. You can make these a little thicker. You can also see your different colors. So if you want to pick out a different color scheme for your data, you can try that as well. So here, our qualitative palette works fairly well. You can also go in, if you want to change the colors that are used, sort of highlight this here at the bottom. You can change it out in page layout, or you see this little change colors up here. Most software give you the ability to sort of kind of customize these as well, some a little bit more than others. But that's a little quick example, really to sort of show when you go in and you're visualizing your data, you have many different options. And so really thinking about the appropriate visualization type for you and for your project is really, really important. All right, so just to sort of finish up, we covered a lot of information today about thinking about your visualizations, different types, different things to look out for, such as your different color palettes and whatnot, some different resources and tools. I put a link in here to that DataViz catalog if you're interested in checking that out. And then a couple of just general data visualization guides. If you're interested in learning more information, getting some more tips for these. A lot of them are pretty similar to what we talked about today. They just sort of go into a little bit more detail. All right, and so that's pretty much all we have. Last thing I will mention is we do have a little survey for our workshops, and I'll put a link here in the chat to this. But please let us know your thoughts, what you liked, what you want to see more of. This will really be good for sort of making future workshops. This is sort of the first time I've done sort of just a general data visualization workshop. Yes, I can definitely share those links real quick so that you have them now. Awesome. Yes, the catalog is a really, really great resource. I use it myself quite a bit. But I will share these links here. If you're interested in any specific like DataViz topics or software, feel free to put that in the survey as well as we sort of build out these sessions. So there should be all the links, and we will send you a copy of all of the slides and the recording at some point after the session once Zoom has sort of done its thing. All right, with that, thank you very much for attending. I put my email there. If you have any questions or you want to talk more about any of these topics, please feel free to reach out. With that, thank you all very much. Have a wonderful rest of your day.